I've a lot to get through today. Right, okay. So the plan for this week is I'm going to do a few proofs, mandatory proofs, things that you have to learn off, okay? So I'm going to prove the sine rule and the cosine rule this morning. And then I'm going to, when we did the algebra 3, we left out induction. So the plan for the rest of the week is to do induction. There's 3 different types. So I'm going to do type 1 today, type 2 tomorrow, type 3 on Wednesday, and sorry, I'm short today there, and type 1 today, type 2 tomorrow, type 3 on Thursday, and we'll see after that how we're going, okay? Right, so the first thing, as I say, right, I want to prove the sine rule, the cosine rule today, and I want to do the first part of induction, okay? So, right, first thing that we have to do is prove the sine rule. Remember the sine rule was A over sine A equals B over sine B equals C over sine C, right? Remember that's the sine rule, so that's what we're trying to prove, right? Okay, and you have to do it in 2 scenarios, okay, right? So we prove it in an acute angle triangle and in an obtuse angle triangle, because they're the 2 possibilities, right? So there's the 2 possibilities that will come up. So we're going to prove it in an acute angle triangle and an obtuse angle triangle. So the first thing we do is, right, okay, we draw our acute angle triangle, we use our new labels, capital A, small a, capital B, small b, capital C, small c, right, okay. Then we drop a perpendicular from the top vertices down, and I'm going to call that H, perpendicular height. So just be careful, H is height, not hypotenuse, okay? Right, okay. So what I can say then is sine A is opposite over hypotenuse, isn't it? Right, so inside this triangle there's a right angle triangle, small one here, and I can say sine A equals H over B. Right, and then I'm going to rearrange that, so H is equal to B sine A. Okay, right, and then I can say sine B is equal to, so I mean this the right angle triangle is opposite over hypotenuse, which is H over A. Then I'm going to rearrange that, so H is equal to A sine B. Then there's 2 H's there, it's the same H, so I'm going to let them equal each other, so you get A sine B equals B sine A. So then cross multiply, move stuff around, move the sine A underneath here, move the sine B underneath here, and you get A over sine B, A over sine A equals B over sine B. Okay? Now, exact same proof, guys, except this time we have to do it in an obtuse angle triangle, okay? So in order to, when it's obtuse, the perpendicular height is on the outside, okay? And in the right angle triangle, this is 180 minus B. Okay, so B is not in the right angle triangle, but 180 minus B is. So that's the angle 180 minus B. So A is in the big right angle triangle, and 180 minus B, that angle, is in the small right angle triangle. So here we go, sine A in the big right angle triangle. So big right angle triangle is opposite over hypotenuse, which is H over B. So that means H is equal to, so that implies that H is equal to B sine A. Okay, then in the small right angle triangle, it's not B now, it's sine of 180 minus B is equal to H over A. this is A, sorry, I never wrote in A there. H over A. Right, now, just on the, you needn't draw this down, so Sex and the City, right, okay, so if we have an angle here, right, the sine of it is positive, right, and 180 minus that angle will be there, the sine is also positive. So the sine of an angle and sine of 180 times the angle is the same angle, right, okay, it's the same sine and everything because it's positive, positive, okay, so that means H is equal to A sine, so instead of 180 minus B, I can just write B because I get the same answer, because if B is in here, 180 minus B is in here, and it's also positive because sine is positive in there also. Okay? So instead of 180 minus B, you can just write B. I have two H's two H's, so I can let them equal each other. So B sine A equals A sine B, and just move stuff around then. So bring the sine B underneath here, bring the sine A over here, and you get B all over sine B equals A all over sine A. Now we didn't prove the equals C over sine C, but you can just say similarly, if you just use different angles, you'll get C over sine C. Okay?